example problem with you so that you guys are going to go ahead and have a little more visuals on limiting reactants. And again, I want to give you guys some practice, and then we'll go through a couple of mole conversions as well, just to double check and to make sure that you guys understand all of the other mole conversions that we haven't been talking too much about. Okay, so we have an equation, and we're going to work with Al plus Br2, and that makes AlBr3, right? So we're going to go ahead and we're going to look at this, right? You will see that I have 2 Brs here and 3. I have 1 Al and 1 Al. So the big thing that I got to balance is my bromines, right? So what I'm going to do is that I'm going to try to even this thing out. So I'm going to add more Br3s. So I'm going to have my bromines here. And on this side, I'll have 6. And on this side, I only have 2. So the way that I can balance this thing out is that I'm going to put another 2 right there. And this should be 3. And then I look at this, and I see that I have now this amount changes, right? So now I have 2 aluminums, which means that I'm going to have to put a 2 right there, right? And now I check everything out, and I see that everything is balanced. So now that everything's balanced, I'm going to go ahead and I can actually solve a problem, right? So in this reaction, it says that there's 50 grams of Al, whoopsies, and 400 grams of bromine. Oh, my bad, it's 40. My bad, not 400. And we have to go ahead and we have to figure out which one is your limiting reactant. Right? So what you guys are going to do is that you guys are going to look at this, and we're going to start with our 50 grams of aluminum, right? And then with our 50 grams of aluminum, we are going to go ahead and you will check on your periodic table, how much does 50 grams of aluminum weigh? So looking at your periodic table, you guys will see that aluminum weighs about 27 grams of aluminum in 1 mole of aluminum, right? And then we're going to go ahead and we're going to use the mole ratio. So for every 2 moles of aluminum, there is 2 moles of AlBr3, right? Then I'm going to go ahead and convert it to AlBr3. So for every 1 mole of AlBr3, there are how many grams? So I have 26, and then bromine weighs about 80. So I have to go ahead and I have to do this math. So 80, so that'll be 160 plus going ahead and adding that 27. And so that'll be about 187 grams of AlBr3. So I would go ahead and I would multiply those things out. So 50 times 2 times 187. So I had 50 times 1 times 2 times 187 grams of AlBr3. And I divided by 27 times 2. And times 1. And then I should get this at the top over 27 times 2, oopsies, 54 grams of AlBr3. So 18700 divided by 54. And then you should get 346.29 grams of AlBr3. Right, so that is the first part. Then we have our 40 grams of 40 grams of Br2, my bad. So I have 40 grams, I'm going to do the same thing. So 40 grams of Br2, right? And then I have to find out how much bromine weighs again. So that is about 80. So 80 and 80, that's 160 grams of Br2 is 1 mole of Br2. And then I go ahead and I do the mole ratio again. So 1 mole of Br2 is 3. Yes. No, 3 moles. Whoopsies. I messed up. So there's 3 moles of Br2, and then there's only 2 AlBr3s that are produced. There you go. And now I go ahead and now I do that same conversion that I did at the end. So there's 187 grams of AlBr3 over 1 mole of AlBr3. So then I would multiply those things across. So I go ahead and I multiply those things across. So 40 times 2 times 187 is 14960 divided by 160 times 3, which is 480. And then this is grams of AlBr3. So I'm going to go ahead and I'm going to divide that. 14960 divided by 480. And I should get 31.16 grams of AlBr3. Right? So then you guys would just compare and contrast these answers. And what you would see is that Br2 is your limiting reagent.